Man, this is like part 5, man. We're getting close. It's like part 5. And here's Mrs. Ryan, just loving on the Jolly Ranchers. So check this out. Day one, whilst at home, she ate 3 Jolly Ranchers. Astonished, her husband challenged if she could eat every day anymore. Challenge accepted, Mrs. Ryan claimed that she would eat triple the amount she ate the previous day, and now we need to create a table and a graph for this whole situation. So check this out. 1, 3, okay. Fair enough. That means on day 2, if she tripled it, that means times 3. So that's going to be 9. Mrs. Ryan, that's a lot of freaking Jolly Ranchers. But it gets worse. If I take that, multiply by 3, get 9. Now I'm at day 3, and I'm at 27. That's still times 3. Times 3 again at day 4, I'm at 81. Okay, confirm. Next I'm at 243. And next I'm at 729. What I'm doing is just taking the previous day and multiplying it by 3. I do have a curiosity, though, which is this first one, day 0, so to speak. But we can do this pretty easily because we know if we multiply, go down, we divide, go up. So that means 1 is where that fakely starts, which kind of makes sense because, I mean, if I know Jolly Ranchers, we always start with 1. But we can never stop at 1. That's just how she works. Now we got to take that thing and graph it. Now the bottom of the graph seems pretty obvious. That's going to be your days. And counting, I think, is also going to be obvious. I think I'll just count by 1s. Now here is going to be a little bit worse because I got to get to 729. So what am I going to count by? Let's see. I could count by 100, skipping some because I'd be like. So let's see, 1, 2, 3, 4, 5, 6, 7, 9, 10, 12, 13, 14. I could count by 50, so in other words, that could be 100. That could be 200. That could be 300. That could be 400. I think it's going to work out. This could be 500. 600, yeah, this could be fine. 700. And then this is going to be 800. So what I was doing is I was kind of testing that out. And I was saying, well, that's 100, 152, and I was trying to get up there. I was just kind of counting in my head. So this seems like a pretty good scale. This is going to be Jolly Ranchers eaten. That's going to be days. Let's graph this dude. I don't know. Let's graph Jolly Ranchers happy. Let's graph happy faces. So 0, 1, man, that's going to be hard to graph. That's going to be way down the list here. It's not really at 0, but I think it's just slightly above 0, so let's move that up just a little bit. Okay, 1, 3. So 1, I don't think it's moved very much. 2, 9 still hasn't moved very much. 327. Now we're cooking. 481. 5. Oh wow, look at that. 243. Mrs. Ryan, you are just stacking on the Jolly Ranchers. 6 to 729. That's gonna be right there. Now what we see here is a very kind of classic curvature, which you guys have known to call the exponential curve. Also, if you kind of consider that, ooh, look at that, that kind of got away from me. Also, consider that this table's changing by multiplication. It all leads us to definitely how this belongs to the exponential family. Now here's the deal, if it's an exponential family, I know it's got to follow y equals a times b to the x power. Now let's figure out the pieces. A is your y-intercept. I can get that from my table. My graph isn't great for getting that, but my table is. And you know, even if I didn't have the 0 days in there, I certainly could count back by using division. If you multiply going forward, you divide going backwards. So 3 divided by 3 is 1. So I could definitely gather what my y-intercept had to be no matter what. Now b is your common factor. She said triple from the beginning. That's a times 3. So that's going to be your common factor, your b. So let's fill in the y and the x, and booyah, we got our equation. Okay. Now it fits what we have here too. We have a pretty fast-growing curve times 3 starting at 1. Okay, so we're good. Now, if this pattern of insanity continues, how many Jolly Ranchers will she continue on day 14, 2 weeks later? Use a rule to figure this one out. And the reason we have to use a rule, I mean, I guess we could extend our table out to 14, but the graph does not do us very much good because, well, I mean, I'm doing it by hand. It's messy, but also we have no more graph left. Now, if we know the pieces of the equation, though, we could just use that. We know x is along the bottom of this. graph, and therefore that's going to stand for days. The Y is along the spine. That's going to be Jolly Ranchers. So if I want to know how many Jolly Ranchers are going in day 14, I just fill in the missing pieces. I don't know the Y because as Jolly Ranchers, she's still starting one and tripling, but now she's going to eat this for 14 days. Okay. So now I got to go to my calculator. I don't know what 3 to the 14th power is, but I do have a calculator that helps me tell that. 3 to the 14th is going to be, wow. I'm going to pause this and write my calculator and go. Okay, I wrote the number. 3 to the 14th is 4,782,969 Jolly Ranchers times 1, but that's silly. I'm not going to write that. So on the 14th day, she will consume 4,782,969 Jolly Ranchers and then slip into a sweet, sweet sugar coma because, I mean, it's going to be sweet because the Jolly Ranchers, bad because of so much sugar. You shouldn't eat that much sugar, kids. Let's talk about 16 now. This is a crazy question. Not as crazy as it seems, but one we can definitely work with. So this red graph right here is y equals 3 to the x power. We're told that. It's labeled. What we don't know is the other ones are. Now, we are given their equations. We have to pick from the list and tell, again, how we know what is what. Now, this could be pretty easy if you know a lot about exponentials. Mostly, the equation y equals a times b to the x. A tells you that y-intercept, and B tells you that factor, the way how fast it's actually gaining values or growing. So if I look at any of these, we can compare them on those two levels. Now, what's interesting is looking at C, because C actually shares the same y-intercept as y equals 3 to the x. Now, if we tear this equation apart, it's actually 1 times 3 to the x, meaning that if I look at these three options, this is the only one that doesn't have a different number besides 1 in front as a y-intercept. So automatically, this has got to be C. Now, there's another way we can tell too, and that's by looking at this factor of growth. This factor of growth, 1/9, is less than 1. If it's less than 1, that means it's decaying. If it's decaying, that means it's going to be decaying and growing and decreasing. Since this is the only decreasing graph, this has to be C. Now that just leaves A and B for these two choices. Now check this out. Now this we can confirm it because they both cross at 4. Boom, 4 and 4. So we know A and B are at least the right things we should be looking at. But look at the two growth factors. That's 5. That's 3. Which one should be growing faster? 5 or 3? Pause the video, stop and think, and you're back. And hopefully you said 5 grows faster. So if you're looking at A and B side by side, A is growing faster than B, therefore A has to be with the 5 and B has to be with the 3. That's all it is. Now there's other ways you could do it. You could graph these out by hand, you could make tables, but in the end, if you know what the equation's about, you know how the graphs are going to look as a result, you can do this one actually really quickly. Guys, I think it's like 1 or 2 more parts. We're getting real close to the end. So check back for the last part of this video in just a few seconds.